So we will do one more example in chapter 11, but before we do, I do want to mention briefly that you can view the solution to the previous problem that we worked on in the previous video in the book. So the problem we just did was example 11.12. All right, and I encourage you to view the solution in the book in case it was hard to follow the solution as I worked it out in the previous video. But keep in mind that the way that I worked it out is very similar, if not the same, as how the book worked it out. But it's always good to see how the book explains it, just so you understand it a little more. Okay, so let's go on to the next example, which says that the patient weighs 80 kilograms and must receive dopamine hydrochloride at the rate of 3 micrograms per kilogram per minute. Okay, so this is another example of a compound rate. Okay, so the amount the patient receives is based on their weight in kilograms and the amount of time in minutes. Okay, so the first part of the question asks, how many milligrams per minute should the patient receive? Okay, so we're going to convert this compound rate of 3 micrograms per kilogram per minute. So let's go ahead and write that out. So 3 micrograms per kilogram per minute. Okay, so the units of micrograms go in the numerator, and then the kilograms and minutes go in the denominator. All right, and you can separate them with the multiplication symbol. Okay, and what we're going to do is we're going to multiply this compound rate by the patient's weight, which is 75 kilograms. Okay, and what's going to happen is that we're going to eliminate the units of kilograms from the patient's weight and in the denominator of that fraction. Okay, so to figure out what this is, we're going to do 75 times 3. Okay, which is equal to 225. All right, so this is equal to 225 micrograms per minute. So that's the dosage rate per minute. So micrograms per minute. All right, now obviously we need to convert that into milligrams a minute. Okay, so we'll do that very shortly. Okay, so now we have the dosage rate in micrograms per minute. So remember, 1 milligram is equal to 1,000 micrograms. Okay, so we're literally going to divide this by 1,000. So in 1 milligram, we have 1,000 micrograms. Okay, that's something you should know already based on our study of the metric system a few weeks ago. So we're going to divide that by 1,000. 225 divided by 1,000 will give us the dosage rate in milligrams a minute. So the units of micrograms are eliminated. Okay, so 225 divided by 1,000. All right, is equal to 0.225. So it's 0.225 milligrams per minute. Okay, is the dosage rate. Okay, so once again, to start the problem, right, we are applying the basic formula that says that the size of the patient multiplied by the order is equal to the dosage rate. Okay, it's understood here that the order is given as a compound rate, as it was in the previous example we worked on, and as it is in the current example that we're working on. Okay, so we took the patient's weight in kilograms. So let me see here. Okay. So I did make a mistake, so I apologize. So it's actually 80 kilograms is the patient's weight, not 75. Okay, so I was confusing that with a different problem. Okay, so 80 kilograms is the patient's weight. So 80 times 3. So let me just quickly fix this. So 80 times 3, okay, is equal to 240. So you replace that 225 with 240. Okay, and then 240 micrograms into milligrams. So 240 divided by 1,000. Okay, it's 0.24. Okay, so 0.240 milligrams per minute is the dosage rate. Okay, so I apologize for the mistake there. But in any case, the process is still the same. So patient's weight multiplied by the compound rate will give us the dose rate, in this case in micrograms per minute, and then we needed to convert that into milligrams per minute, okay, by dividing by 1,000, and then we get the corresponding dosage rate in milligrams per minute. The second part of the question is asking, so how long will it take for the patient to receive 50 milligrams of the drug? Okay, so in other words, we're being asked to convert 50 milligrams into a time in minutes. Okay, and if necessary, if it's more than 1 hour, we can convert it into hours and minutes. Okay, so we have 50 milligrams. Okay, so what we're going to do then is multiply the amount here of 50 milligrams, okay, by 1 minute. Okay, over 0.240 milligrams. Okay, so the question is, how do we know to put what where, right? How do we know to put 1 minute in the numerator? All right, and then the 0.24 milligrams in the denominator. So for obvious reasons, right, that allows us to eliminate the units of milligrams. Okay, but in case it isn't so obvious, right, our answer to the previous question, we're using our answer to the previous question to answer this question. Okay, so that 0.240, which I've written off to the side, okay, if I write it as a fraction, right, that 0.240 belongs in the numerator, right? So that's the number of milligrams the patient is receiving per minute. Okay, and we have 1 minute in that denominator. Okay, so anytime you see a number off to the side, okay, assuming that this is not a mixed number, which it isn't, right? It's a rate, right? That number here goes with the numerator. Okay, so that's how I knew to put then the 0.240 in the denominator and then the 1 minute in the numerator, right? So therefore we're going to get 50. We're going to do 50 divided by 0.240. 50 divided by 0.240. Okay, 0.240. Okay, and we get that number there, so 208.33333. Okay, we can round that. So this is 208 minutes. Okay, so 208 minutes is the length of time it will take for the patient to receive 50 milligrams of the drug. Okay, but let's say that the answer in the book is given in hours and minutes rather than in minutes. Okay, so it's an easy task to go from minutes into hours and minutes. Okay, so on your calculator, you can literally do 208. All right, so obviously we've rounded the answer to the nearest whole number. Okay, so take the number of minutes and divide it by 60. Okay, we get 3.46667, right? So it's a little more than 3 hours, right? So fairly close to 3.5 hours, okay, but a little less than 3.5 hours. Okay, so it's 3 whole hours. Okay, so 3 whole hours. Okay, that's what the whole number means, so 3 whole hours. All right, and a certain number of minutes. Okay, so that 0.666667, right, is part of an hour. Okay, not quite a full hour. Okay, so we know it's 3 hours and some portion of an hour. Okay, so let's go ahead and subtract the number of hours from our answer. Okay, so we're left with the decimal. All right, so to get that number of minutes, since it's not a full hour, okay, we're going to multiply that 0.466667 by 60. All right, so you get the appropriate number of minutes. So keep in mind, do not round this decimal, right? Keep it as it is. Okay, so we multiply that by 60, it should give us the number of minutes. Okay, so for the patient to receive 50 milligrams, right, it'll take approximately 3 hours and 28 minutes. Okay, so the dosage rate in the previous part allowed us to figure out the amount of time in this part of the question. Okay, and then we converted the total minutes into hours, as I just showed you. Now this is also an example from the book, so in fact it is example 11.14. And again, I encourage you to review the solution and compare it to how I worked it out. Okay, it does look like in the second part of the question, right? They take the similar approach. Okay, so I see, right? So they take the 50 milligrams and convert it into micrograms. Okay, but remember the dosage rate should already be given in milligrams. So let's see. Right, it does ask for the answer. So there might be some typos. So just be aware that the book has typos. Okay, but basically, part A asks for the milligrams per minute. So this should be 0.24 milligrams a minute, but it has 240 micrograms a minute. Okay, so they did a little extra work here, right? So if the dose rate is already in milligrams a minute, you don't need to do all of this here. You don't need to do that. Okay. Anyway, so they get 3.472 hours in the process, which they rounded up to the nearest half hour. So the book has 3.5 hours as the answer here. So hopefully that's not too confusing. If you have any questions, please let me know. And thank you for watching.